In proof number 40, I'll start the same way I always start my proofs, by marking the given information. I'm given that BD is congruent to DC and that AD is perpendicular to this segment BC. Well, perpendicular means that I have right angles, so I can put two right angles right here at the bottom. And then I'm trying to prove that angle DAB is congruent to angle DAC. And I notice those are two angles that are parts of those two triangles on the left and the right. So I'm thinking if I can prove those two triangles congruent by CP/CTC, I'll be able to grab the corresponding parts and say that they're also congruent. And looking at this, I see that AD is reflexive to both triangles, and with just that I've marked, I've got a side, an angle, and a side that's matching up to a side, an angle, and a side. So these two triangles have to be congruent, which means those two parts are also congruent by CP/CTC. So let's see if we can write that clearly. I know that BD was congruent to DC, and I know that AD was perpendicular to BC, because that was given. The next thing that I marked on the picture was that angle ADB and angle ADC are in fact right angles. Again, people sometimes confuse putting that in there because of the perpendicular and then forget to write it down. I mark the right angles because I know that perpendicular means that it makes a right angle. So I'm using the definition of perpendicular to make that marking. And then I know that if they're both right angles, I know that angle ADB is congruent to angle ADC because of a theorem we haven't used for a while that says all right angles are congruent. And you may be thinking, well, why do I need to write that in my proof at all? Well, to use side angle side, like I said, I'm going to have to show that I have a pair of sides congruent, a pair of angles congruent, and another pair of sides. So if all I say is that I have right angles, I'm leaving my reader to assume that I know they're congruent. So I need to clearly state that. The only other thing I marked for that side angle side relationship was AD reflexive to itself, so I do need to mention that. So AD is congruent to AD because of the reflexive property. So in statement 5, I should be able to say that those two triangles, ADB and triangle ADC, are in fact congruent because I have a side angle side relationship. And then if the triangles are congruent, I should be able to say my final statement that DAB is congruent to angle DAC because the corresponding parts of those congruent triangles are congruent, CP/CTC. So as I look back, I want to double check. I made a side angle side relationship, so I need to check. I mentioned one pair of sides here, BD and DC. I mentioned the right angles, but really what I'm interested in is that I have congruent angles. That's why this statement about them being congruent because right angles are congruent is important. There's my angle for my angle or my side angle side relationship. And then I did say the third set of sides there, AD to AD. So I have a nice side angle side matching a side angle side. I listed that in my proof, so I'm ready to say CP/CTC and take the parts that I want.